Hey everyone, welcome to the Code Studio, and in this video I'm going to tell everything you want to know about recursion in computer science. So let's jump into the what is recursion part. Recursion, as the word suggests, is something that occurs repeatedly. Recursive function in computer science refers to the function that repeatedly calls itself during the time of execution. It shortens the code and makes some problems and data structures easy to understand or comprehend. Converting a given problem into a recursive way of analysis and solving it might look difficult in the beginning, but gaining practice and thinking problem statements in this arena would make the task easier. Some questions are only solvable with recursion, and some of the data structures are solely dependent on recursion. So you definitely need to know how recursion works, and you need to know how the recursive functions are written and executed. So I hope this series might help you. As we have discussed now, recursive function is something that calls itself again and again. To have a clear understanding of what that actually means, let me explain to you a recursive algorithm to calculate the power of a number, and using the same example, I'll explain to you all the things you need in your backpack for recursion. So a problem statement here is to calculate the power of a number. Both of the base and power are given as input by the user. There might be different approaches for this particular problem statement, but since we are here in the recursion series, we need to think only recursively upon this statement. Okay, recursive thinking, start. Let us choose an example like 2 to the power of 4. So we are asked to calculate the value of 2 to the power of 4. Here 2 is the base and 4 is the power, both of which are provided by the user. 2 to the power of 4 can be written as 2 into 2 into 2 into 2. Not written. The definition of 2 to the power 4 is this, right? 2 multiplied by itself 4 times. Okay, fine. So 2 to the power 4 is written like this, and as you already know that these three things can be combined or regrouped to form 2 cube, right? So I'll rewrite this thing as 2 to the power of 4 can be written as 2 multiplied by 2 cube, right? And we know that 2 cube is 2 into 2 into 2. We also know that these two terms can be recombined to form 2 square, right? So I'll redefine 2 cube as 2 cube is equal to 2 into 2 square, and 2 square can be written as 2 into 2, where this 2 can be written as 2 power 1, and in our summary we'll write 2 square can be written as 2 times 2 power 1. So this is how 2 power 4 can be expanded. 2 power 4 is 2 into 2 cube, and 2 cube is 2 into 2 square, and 2 square is 2 into 2 power 1. So the above summary can also be written in this way. 2 power 4, so 2 power 4 can be written as 2 into 2 cube, and 2 cube can be written as 2 into 2 square, and 2 square can be written as 2 into 2 to the power 1. And this is connected like this. 2 power 4 is given by this thing, and 2 cube is given by this thing, and 2 square is given by this thing. In our algorithm, when the power is 1, we provide the value to the function. So when a 2 to the power of 1 is stuck upon us, like the power is 1, we provide its value, its original value. That's 2 power 1 is 2. So we gave a value of 2 to this. So 2 into 2 is 4, and 4 value is sent to 2 square, and 4 into 2 is 8, and an 8 value is sent to 2 cube, and 8 into 2 is 16, and a 16 value is sent to 2 power 4, and finally 2 to the power of 4 received its answer as 16. This is how a recursive algorithm is used. Wait, what? A recursive algorithm? I didn't see anything calling itself. Okay, let me go back and show you what is the calling itself part. So now let us define a mathematical multivariable function f, and the parameters in the function would be xn. So it's a 2-variable function f of xn, and in this case f of xn can be written as x raised to the power of n. This is the mathematical definition of the function we have just assumed, and this function gives a value of power of a number. Here x is chosen as the base and n is chosen as the power. This is what that actually means, right? X power n. So we give two values to the function as 2 and 4, and this function just finds the power that is 2 to the power 4, which is what our last example was. So to calculate the value of 2 power 4, we broke this down into a smaller component, that is 2 into 2 cube. So here also we'll break down this complex thing into a smaller sub-instance so that we can easily solve our problem. So as we have declared here that 2 power 4 is 2 into 2 cube, so we can declare that x power n can also be written as x times x raised to the power of n minus 1, and this in functional notation is nothing but f of xn can be written as x multiplied by f of x comma n minus 1. This is what is called as a mathematical representation of a recursive algorithm. The calling itself part here is visible clearly. A function f of xn calls the same function f with varied parameters to solve the algorithm. It calls itself with different parameters many times until a result is arised. A common computer programming tactic is to divide a problem into subproblems of the same type as the original, solve those subproblems, and combine the results. In the same way, in recursive method of solving problems, we are breaking down huge problems into replicable subproblems, solving them and substituting them back into the original thing to find the result. So recursive functions f in this case calls the same function f or calls another function g that calls this particular function f with different parameters, that is different input values, to the function until the result is attained. Okay, fine. But how do we know that result is arised in this calling process? The calling process might go on and on and on without knowing where to stop, right? So here's the thing. You need to provide the condition or situation when the recursive calling should stop. So the recursive algorithm or function has two parts in it: a base case and a recursive case. A base case is a condition where the function produces the result trivially without recurring through the algorithm. It breaks the chain of recursion, so it is sometimes called the terminating case. Recursive case. Recursive case is that condition where the function calls itself and recurs through the algorithm until the base case arises. The job of recursive case can be seen as breaking down complex inputs into smaller ones. Neglecting or forgetting to write a base case might lead you to some terrible situations which you can't handle. An infinite loop. Why? Why is there an infinite loop? Since the base case is not mentioned, only recursive case is being called and the calling goes on and on and on and leads to an infinite loop. Okay, so better would be make sure you write in the base case when you code for a recursive function. Let us now find out the base case and recursive case in our example of finding the power of a number. In our recursive function, we call the function again and again until the power becomes 1, right? So the base case or the terminating case in our example would be when the power is 1. And in all other cases, when the power is a non-1 positive quantity, the breaking down and calling functions go on and the recursive case breaks, leading to the base case. So the breaking of recursive cases occurred by decreasing the value of power by 1 in each scenario. Let us summarize this recursive algorithm used here in a mathematical form so that we can use it in our code. So a function f of xn is defined where it can be written as the function f of xn returns the value of x if the power is equal to 1, that is n equal to 1, and the function f of xn returns a value x times f of x comma n minus 1 in all of the cases where n belongs to positive integers minus 1. So this is a mathematical representation of a recursive algorithm, and this is known as a recursive pseudocode, which is very necessary before you start to code. You need to write down the mathematical representation for every recursive algorithm before you start coding and then code in your language of choice. So let us code for this recursive algorithm in our text editor. I'm going to code for the power of a number recursive function first in C language. I have my text editor open on my screen, and I saved the file to power_recursion.c. So let's include the basic header file first, and let's write the recursive function declaration initially. So the recursive function finally returns an integer value, right? So it's an int, and let's name the recursive function as power recursion, something like that, power recursion, and the input values would be x and n, as we have written earlier in the pseudocode, and both of them are integers, so int x and int n. So this is the basic recursive function template, and let us also write down the main function. So let's ask the user to enter the base and power. So let's declare two variables in base and power, and let's input them. So print enter the base, and let's scan the input given by the user. So it would be an base, so we provided the address to base, and let's also ask the user to enter the power of the number, enter the power, and let's also scan and assign it to the memory address named power. Fine, the base and power are given, and we need to call the power recursion function here, giving the input as base and power, and let us find out the output, what does it produce. So let's jump into the power recursion and finish the recursive code. So as you know, we need to write a base case and a recursive case in our code to complete the recursive function. So the base case would be if the value of power is equal to 1, then the function returns the value of x. Fine. So the base case is written perfectly fine, and let's also write down the recursive case. So recursive case is not an else case, because the power cannot be negative, but integers can be negative. So let's only take the inputs for positive integers. So it's an else if case. So else if n is a positive quantity and non-1, because the case when the power is equal to 1 occurs in this scenario, and in this scenario we'll only write down the non-1 positive quantities. Now, so this elif part is for non-1 positive quantities. So when the n is positive and not equal to 1, the function returns a value of x times the function. So the function here is power recursion with an input, with a varied input, basically x comma n minus 1. So this is what the recursive function returns in a recursive case, and in the base case it returns the value of x. Fine, so the recursive function is completed, fulfilled. Now let's call the recursive function in our main function. So I'll directly print the answer. So I'll print like the percentile d raised to the power of percentile d equal to percentile d. So let's directly print the solution here. See, the first argument would be base in the printf statement, and second would be power, and the third would be the power recursion with the inputs as base and power at their respective positions. So see, the first one is base, so base raised to the power of power equal to the answer. The answer is found by the power recursion recursive function. So I feel the code is fulfilled and completed. Oh wait, the print is not print, it's printf basically. Okay, fine, let's save it and compile it, and let's check if our answer is coming or not. So I'll run the program we have just seen, the power recursion. So let's run it and just check if it's working fine or not. So enter the base. So our sample test case was 2 power 4, right? So the base would be 2 and the power was 4. So the answer 2 power 4 equal to 16. Okay, it's working perfectly fine. Let's check for another input and let's see if it's working fine or not. Like, we can't rely on a single test case, right? So let's enter the base as let's say 5 and the power as 3. It should be 125. Yeah, 5 cube is 125. Fine, it's working fine. So yeah, my code worked fine, and the recursive function we did code for was running perfectly well. So this is how you write a recursive function in C. First you write a pseudocode, then convert into a perfect code. Write the base case and the recursive case without fail, and then run and just check. So here I have my code editor open, and with a new file named powerrecursion.py. So py, as you have guessed it, I'm going to code in Python now. So we have already pseudocoded the power recursive file earlier as the function f of xn. So like we have declared a multivariable function f of xn, and we have written two cases, the base case and the recursive case, perfectly well, and we have seen the pseudocode was working well. So now we have to replicate the same in our Python code. So we'll define a function initially as power underscore recursion, and we'll give the inputs as x and n. It's a two variable, the same multivariable function. We need to write the base case and the recursive case, right? And recursive case, the base case and recursive case are like two hearts for the recursive function. So we definitely need to write the base case and recursive case before moving forward into any other thing. As we have discussed in the pseudocode, the base case was if the power equal to 1, then the function should return a value of x, right? So I'll write the same thing. If power equal to 1, the function should return the value of x. And we need to write the recursive case now. So the recursive case wouldn't be an else case in this case. Case. Okay, so the recursive case, let's name it condition. Okay, so the recursive condition, so the recursive condition wouldn't be a else case, because not all integer powers are taken into this recursive function. Only positive integers are taken and the power of a number is calculated. If an input like 10 raised to the power of minus 1 is given, we can't replicate the same process we did for the positive quantities here. So this code won't work for negative powers. Okay, we can modify the code later for so that it can work for negative powers also later in our videos. But this particular pseudocode we did discuss, it doesn't work for negative powers. Right, so we need to give the recursive condition only for positive integers, which are powers of the num function, like the n inputs, and it shouldn't be a 1. Obviously, it wouldn't be a 1. If it is a 1, it jumps into the base case and x value is written. Okay, so we'll write an elif here. Elif n is a positive quantity. Wait, let's indent it properly. Python, right? Indentation is necessary. And the function returns a value of x multiplied by power recursion, and it should be x comma n minus 1. So it is decreasing by a quantity of n, right? So we are out of this function. The recursive function is completed. We did write for the base case and write for the recursive case, sorry, condition. Right, now let's ask the user to input the base and power. So base equal to input, enter the base, right, and it is stored in a base variable. And let's also input power. Enter the power, it's stored in the power variable. And now let's print the answer directly, which is base raised to the power of power equal to answer, like the integer written by power recursion. If the base is given as 2 and power is given as 4, the answer should be printed as 2 power, like 2, let's comment, like 2 power 4 equal to 16. So how do we do it? Let's print it. Print, let's give 3 parameters. So this thing, print this thing equal to, so we're giving 3 parameters. So the first one would contain the base, okay, and the second one would contain the power, and the third one would contain the answer. Okay, so let's give the values. Format, so the first one would be base, the second one would be power, and the third one would be power recursion, inputting base and power. Perfect. So base raised to the power of power gives the answer. Let's delete this shit. Okay, this code should work fine. I'll just compile it and check whether it's working fine or not. Let's compile the Python file we just did code for. So Python power recursion.py, right? We are asked to enter the base. So the base would be 2 and the power we had was 4 and 2 to the power of 4 is 16. That's what we intended to print, right? And the answer is also right. Okay, so it's working fine, but we can't rely on single test case, right? We need multiple test cases. So let's just check for another test case and see whether it's working fine or not. So I'm running the code again. Now let's input the base to be 5 and the power to be 3 and let's just see if it's working fine or not. Yep, 5 cube is 125, 5 raised to the power 3 is 125. So the code is working fine. So this is how we just did code for recursive function in Python and C. First analyzing the logic, finding the base case and recursive case, writing down the mathematical representation of recursive function, and then coding for in your language of choice. So the take home things from this video are: a recursive algorithm is used only when the function has a solution that depends on the solution of smaller instances of the same problem, which can be replicated with varied arguments. Recursion is an efficient method of coding as it reduces the code and makes the comprehension way easier. However, the recursive algorithms must be incorporated carefully because an infinite loop caused due to omission of base case leads to the termination of function completely. A recursive case must change its state and move towards the base case during its process of implementation. A recursive pseudocode is written using the mathematical definition and pseudo-programming. Then the algorithm is applied in the program using the language of your choice. So that's all for this video, wherein you have learned the basics of recursion and how a recursive algorithmic function is pseudocoded, and then coding for the same in C and Python. Alright guys, see you in the next video. Signing off, Saiankit, Code Studio.